Good morning or good afternoon again. Today we will be proving that the line segment YZ is congruent to line segment WZ by using a two-column proof in our given statements and also the figure to your right. Alright, so let's get started. So we always start with our given information. So the reason for this first information is YX is congruent to WX. It is given to us. Alright, we're going to actually mark as we go. So YX is congruent to WX. Okay. Our next statement is also given to us, but it says last segment ZX bisects angle YXW. So if it's an angle, it's mostly focusing on the X, the middle letter. So YXW. So if it's bisected by ZX, that means it's going to be cut in half. So the angle gets cut in half, making two equal angles. One angle is here, and the other angle is right here. Same angle. So now you have two new congruent angles. YXZ is now congruent to WXZ. The reason why is by definition of angle bisector, which made these two angles congruent to each other. Okay, now let's look at the next statement, which says that XZ is congruent to XZ, which is a pretty true statement. You can look at XZ and tell that it's only going to be congruent to XZ. So if you look at that statement, it's right here. The reason for XZ to be congruent to XZ, think about it. Most of you have already thought, yes, reflexive property. Reflexive property. Okay. So now let's actually mark that on our actual triangle. So if XZ is congruent to XZ, now if it's getting split, it doesn't matter because it's XZ. So XZ is congruent to XZ, and we actually make this mark. We should see one of our congruency statements for triangles. So now for the fifth statement, triangle YXZ is congruent to triangle WXZ through which congruency statement, everyone? You should be able to see it. It is simple. Side angle side congruency statement. Congruency for triangles. Side angle side. And lastly, if we prove that two triangles are congruent through either one of our congruencies, then we can say, so this triangle is congruent to that triangle. That also means that the corresponding parts of those triangles are congruent. So that would leave that YZ must be congruent to WZ through what is called definition of congruent triangles, or other words, CTC, and it's short for corresponding parts of congruent triangles are congruent. And to give you an idea what that means, so CTC, corresponding parts of corresponding parts are, let me get that right, corresponding parts of congruent triangles are congruent. As you see, CPCTC, CPC, T, and C. Okay, let's take a look at it. Let's just say we had two congruent triangles. We have triangle 1 here, and just to make sure that they are congruent, let's copy it and move this one to the side so I can paste it. So we got two identical triangles. Alright, one is let's say this triangle is triangle A, B, and C. Simple concept. Alright, this one would be, yes, let's go in order. X, Y, and then Z. Okay, so let's just show one simple congruency. Alright, one simple congruency. Let's say that angle A is congruent to angle X. Okay, and then side X Z is congruent to side AC. Okay, and then lastly, side AB is congruent to side XY. Okay, this is showing congruency through what? Side, angle, side, right? Showing that two triangles are congruent through side, angle, side congruency. But what about the third side? Because AC, if you look at all the corresponding parts that are going on right now, you got AC, which is here. AC is corresponding to XZ, and they are congruent. Okay, angle A is corresponding to X, and they are congruent. Okay, angle B, side AB is corresponding to XY, and they are congruent, right? But nobody said anything about B, C, and YZ. Now, they must be congruent because if you have two congruent figures, everything is exactly the same. Okay, so we stated that they are actually congruent through side, angle, side. But it's just basically saying that BC is congruent to YZ through CPCTC. So these sides must be congruent. If I showed, or if I could show that it's congruent through one of my 5 congruencies. Thank you. And you're done.